welcome to my tutorial platform. I am instructor Victor. Now, from my previous videos, I made an introduction on a differential equation, and one of the types of the differential equation that we have is one we call the ODE. The ODE means ordinary differential equation, and we have the second one that we call the PDE, which is the partial differential equation. Now, we are into ODE, knowing some of the things that are under ODE and then solving some questions, and thereby we reach to this particular point, which we are solving a solution of the ODE, which is the solution of the ordinary differential equation. And now we have one of the question down here that we need to solve, and this question says, show that y equal to a cos ln x plus b sin ln x is the solution of the differential equation x square d square y dx square plus x dy dx plus y is equal to 0. But for us to break this down, we have to represent any differential equation into its prime. If you have the square y all over the x square, let us represent it in this form: x square, because it is what a second order differential equation. Let us represent it with y prime prime. Now we have this one here to be x. Now this is a first order differential equation. We represent it with a y prime, then plus y equal to 0. This will help us to avoid being confused on what we are doing. Now, solution to this question, we have that given this, I've replaced this now with this, given x square y prime prime plus xy prime plus y equal to 0. Now we are required now to show that y equal to a cos ln x plus b sin ln x is the solution of the DE, which is what we are given. Now, how do you solve this question? Let me introduce to you once more. Now, if you are solving this kind of question, you have to look at what you are given. You are given y. This is your y. Now you are giving y prime. You are giving y prime prime. From what you are giving here, that shows that you are going to differentiate twice. You differentiate the first one to get y prime. You differentiate the second one to get y prime prime, and then you will stop. Now we are going to start differentiating our function here, which is a y. Our first differentiation will give us the y prime, while the second differentiation will give us the y prime prime, which is the square y all over the x square. Now what we want to achieve is, if we can solve this and then analyze it into this term, and later on find our answer to be equal to what? 0. If our answer turns to 0, that means this particular function is a solution of the ODE, which is the ordinary differential equation. Now let's solve. Now if you have here, we have a cos ln x plus b sin ln x. We have cos ln x and sin ln x. Now in differentiation, we call this function of a function. Function of a what? Function. And we use chain rule to differentiate this. Now what do I call it a function of a function? Y is a function of what? Cos ln x. Look at this. Cos ln x is a function of what? Y. Now ln x is a function of what? Cos x. That's why we call it what? It is a function of another what? Function. The ln x that we have here. Ln x is what? Is a function, and the cos x here is what? Is a function of what? Y. Now how do we differentiate this? How do we differentiate this? Now this leads us to what to call what? The chain rule, which is y prime is equal to, if you differentiate cos here, you are also going to differentiate what what is inside the what? Bracket. Now this is what it means. The ln x, when you differentiate ln x, We already know what we have if you differentiate cos x, but ln x may be a little bit complicated for you. Now, when you differentiate ln x, when you differentiate ln x, now when you differentiate ln x, you're going to be having 1 over x. Just have this in mind. Just have this in mind. I'm not here to show you how we got it, but if you differentiate ln x, you're going to be having y 1 over what? X. So just have that in mind. Now, look at this point. We have a cos ln x. Now, when you differentiate cos, we're going to be having minus. We have our arbitrary constant. That one does not follow the differentiation. The arbitrary constant remains. Now, we have minus a sine ln x. If you differentiate cos ln x, you're going to be having minus a sine ln x. Now, inside the ln x, you also did, that's why I said it is a function of a what? Function. When you differentiate cos, you also differentiate what is inside the what? Inside the what? The cos, which is the what? The ln x. Now, your differentiated cos, you have minus a sine ln x. Now, when you differentiate ln x, you're going to be having 1 over x. So, if you multiply this now by 1 over x, you will have minus a sine ln x all over x. I'm sure you understand what I mean. Now, plus, if you undergo the same thing that is we have here, if you differentiate sine, you're going to be having cos. Now, you have here b cos ln x. Now, you differentiate what is inside the what? A function of what? Sine, which is ln x. You're going to be having 1 over x. But then, when you multiply 1 over x by this, you have this to be over x. As simple as that. Now, you have differentiated or you have gotten your first order differential equation. Now, for us to move over to the second order, which is y prime prime. Now, let us look at this. If you have to differentiate now, we are going to be using another form or another type of differentiation, which we call the quotient rule. And that quotient rule is going to be a more difficult one for us to solve. But then we have to do for a simpler way to get our what? Our answer as fast as possible. Now we have it to be over x. We have it to be over x. Let us multiply through by x so that we can eliminate the denominator, which is x. So when you multiply through by x. Now, what are we going to have? If you multiply through by x, x times y prime will give you x y prime equal to x multiplied by what you have here. You see that the x will cancel what? X. You will be left with minus a sine ln x plus x multiply what you have here. The x will cancel the what? The x on the denominator. You'll be left with b cos ln x. As simple as that. Now, since you have gotten xy prime equal to minus a sine ln x plus b cos ln x, what do you do next? You will now differentiate again so that we can get our what? Our y prime prime. But then, if you are differentiating in this context now, what are we going to? What type of differentiation are we going to use? We are going to use product rule. And we know that product rule is more simpler to accomplish than the chain rule. Now, why are we using product rule? We have a function here and we have another what? Function. We have two functions that are being multiplied together. And to execute this function, you are going to be what? Applying a product rule. As simple as that. Now you have x, y prime. Now for you to differentiate this now, don't forget our rule. Now let me tell you what to do. You keep one of the what? Function and differentiate the other one. You will now add it and then keep the one that is differentiated and then differentiate the other one. This is what I mean. You have x here, y prime. Now if you want to keep x and then differentiate this one. If you differentiate y prime, you will have what? Y prime prime. That is that. You now keep plus. That one that you differentiated, which is y prime, you keep it constant. And then differentiate x. If you differentiate x, you're having what? 1. Now this is what I mean. You've gotten it. Now equal to, we will not differentiate this one the normal way we differentiate. Now minus a sine ln x. Now if you differentiate sine, you are going to be having cos, but then the minus still remains. You now have minus a cos ln x. Now inside the ln x, you differentiate ln x, which will give you 1 over x, all over x. Now we have plus b cos ln x. If you differentiate cos, when you differentiate cos, it will turn to minus sine. So this will now give us minus b sine ln x. Now when you differentiate the ln x that is in the function, you will have it to be what? Over x, which is 1 over x. When you multiply it, you have 1 over what? X. Now what do you do next? You now have xy prime prime plus y prime of 1 equal to minus a cos ln x all over x minus b sin ln x all over x. Now what do you do? Let us remove the x that we have here by multiplying through by x again, just as we did here. Now when you multiply through by x, now what are we going to have? If you multiply this here by x, what are you going to have? You are going to be having x square y prime prime plus, if you multiply this by x, you will be having x y prime equal to, if you multiply this by x, you eliminate this, you now have minus a cos ln x. Now if you do the same thing here, this x will cancel the x you are multiplying through. You will now be left with minus b sin ln x. I'm sure you are following what I am doing. Now what do we do next? Let us compare by comparing. We have x square y prime prime plus xy prime. Now if you look at this now and look at one of the functions we have here, x square y prime prime plus xy prime, we have it here, x square y prime prime plus xy prime. You see that from the product rule that we used, we were able to get parts of the solution which we are given. So x square y prime prime plus xy prime is minus a cos ln x minus b sin ln x. Now the only thing we now have to do is to add it y, and the value of y is a cos ln x plus b sin ln x. So for us to achieve that, we have to now x prime prime x square y prime prime plus xy prime plus y. So we already have this as this, which we have here. We now have minus a cos ln x minus b sin ln x plus y. Now this is our y. Our y is a cos ln x plus b sin ln x. If I'm not seeing it very well, this is our y. Now we are going to add it by a cos ln x plus b sin ln x now equal to 0, because what we did here is the combination of all this equal to 0. Now let's see if this will be equated to what? 0. Now we have minus a cos ln x, and then we have here plus a cos ln x. Automatically they will turn to what? 0. Now we have here minus b sin ln x, and we have here plus b sin ln x. Minus plus, they will automatically turn to what? 0. Therefore 0 is equal to 0. Now from this, it will tell you that the function which is a cos ln x plus b sin ln x is a solution of the differential equation x squared the square y over the x squared plus x dy dx plus y equal to 0. So this is a differential or a solution of a differential equation. And then another thing that you have to understand, this is a general solution. Why do we call it a general solution? because it has an arbitrary constant and does not come with what? An initial or boundary condition. Thank you for watching. Bye-bye.